So I've told you in the past that trigonometry is about angles and triangles. So we need to take a few minutes and go over some information that you probably remember from geometry and talk about angle relations. The first angle relation we want to talk about are vertical angles, and there is a concept that says all vertical angles have equal measure. What that means is I have two lines here that are intersecting, and you can see from this diagram here what it's suggesting is that angles that are opposite each other would be equal in measure. So this angle down here, angle M, would have the same degree measurement as this angle up here, which would be angle QMR. And you denote that, or whenever you see a single line or the same marking on each of those two angles would show that these two angles are the same. Additionally, these angles over here, which are vertical, which are across from each other, are also have the same measurement as well. So the idea that vertical angles which are across from each other in two intersecting lines, these angles across from each other have the same measure. Now let's talk about parallel lines. Okay, so here I have a table which is verbally describing the picture that we have going on over here. The idea behind parallel lines and a transversal. So I have two lines that are defined as being parallel, cut by a transversal, or in other words, some other line that's crossing on top of the parallel lines. And there's a relationship between all of the angles that you have going on in there. For example, we know that angles 1 and 4 would be equal because they are vertical angles. So angles 1 and 4 are equal. But additionally, when you have parallel lines, angle 4 and angle 5 have the same measurement. So alternate interior angles have the same measure. So if angles 4 and 5 have the same measure, then angle 3 and 6 have the same measure. You can keep going from there by saying, okay, if angle 6 is some measure, angle 7 is has the same degree measurement because they are vertical. And I erased it, but there we go. So angles 3, 6, and 7, and angle 2. All of those lines end up having the same measurement. Another thing that you want to remember about transversal and parallel lines, that angle 2 and angle 4, okay, those would be supplemental. So the measure of angle 4 plus the measure of angle 2 is going to give me 180. So I can figure out, as long as I remember the relationship between vertical angles, supplemental angles, and alternate interior, that I can figure out all of the information about angle measurements within here. You also have this idea that you have alternate exterior. So if I'm talking about exterior being on the outside of these two parallel lines, angle 1 and angle 8 have similar measure. Angle 1 and angle 8 have similar measure. And you could come about that doing it different ways, but that's pretty much the crutch of the entire thing. So let's look at an example. Oh, and one more thing that you want to remember, that the sum of the angles in a triangle, right? All of the angles inside of the triangle would have to be equal to 180. Those are three key concepts that we're going to talk about: vertical angles, parallel lines, and the sum of the angles in a triangle. So here we have the first example we want to look at. You can see that I have two. I'm going to tell you that these two lines are parallel, that they are cut by some sort of transversal, and I'm given an expression for each of these two exterior angles, and I want to figure out what the value of x is. Well, because these are alternate exterior angles, I know that they're equal, and therefore I can set both of these expressions equal to each other. So the first angle up here is 2x plus 61. That's going to equal the second angle down here, 6x minus 51, and we solve for x. I'm going to subtract 2x to the right-hand side, and I get 4x. I'm going to add 51 to the left-hand side, and I get 112. Divide both sides by 4, and I find out that x is equal to 28. Now, if I want to find out what the measure is of the angle, then I'm just going to substitute 28 in for x here. So that would look like 2 times 28 plus 61, giving me a total of 117 degrees. So I know that this angle is 117, and I'm assuming, since these are alternate exterior angles, that this value down here should be 117. You can always just check that by saying 6 times 28 minus 51 ends up being 117 also. Okay, so we use the idea that alternate exterior angles are equal to solve for the variable x. Similar concept right here. This time I have a straight line and I have a triangle lying on top of that straight line. I want to be able to solve for the variable x within this. A couple of things I know. I know that the angle down here is given by negative 8x plus 3. The angle up here is given, or the angle up here is given by negative 5x. And I have an exterior angle over here at 7 minus 12x. So the way that I want to approach this, I know that I have 2 of the 3 angles of my triangle, and I know that the sum of those 3 angles would have to equal 180 degrees. So really I've got to figure out what is the measure of this third angle inside of my triangle. Well, that's going to come from the fact that I have supplemental angles right here. So really, this missing value, or this missing angle that is right here, would be 180, right, because it's 180 degrees, minus this measurement right here, 7 minus 12x. And I'm going to simplify that expression. I don't really know, I can't solve for x, but I can simplify it to know what, to be able to represent it in this angle value right here. So I get 180 minus 7 plus 12x, ending up giving me 173 plus 12x. That's the representation of this third angle here in the triangle. Using the 2 given angles with the angle we just calculated, I can add all 3 of those angles together. We'll do that down here. So I have negative 8x plus 3, that's one angle, plus negative 5x, plus the third angle of 173, plus 12x. And remember, all 3 of those angles have to add together to give me 180. So simplifying this side right here, I end up with negative 8x minus 5x plus 12 gives me negative x, and a 3 plus 173 gives me 176 equals 180. So again, all I did was simplify the left-hand side. Now I'm going to subtract 176 over to the right, and I get negative x is equal to positive 4. Then if I divide both of these things by a negative 1, I end up with a positive x equals negative 4. We take what we found x to be, what we solved it to be, and we replace it in each of these values up here. And when I replace it, I end up with this top angle being 20. Okay, because negative 4 times a negative 5 is a 20. If you were to do this angle over here, I would end up with 56 for the value or the measure of that angle. And then finally over here, this interior angle I have, or this third angle I have on the triangle, ends up being 35.